So this is video number 3, and on this video number 3 we're going to have our oscilloscope on test point number 2, and this is the very important signal. This is the voltage controlled oscillator that it's again biased at 5 volts, and this is the one that has the frequency again at 5 milliseconds per division, so at about 16. Here we have all the humps controlling our SCRs. This is the signal that it's again critical. 5 milliseconds, and we can count 3, 6, 9, and 12, and that's 16.6 milliseconds. The following signal is going to be moving around. Right now I have it on test point 15, and on test point 15 it's a signal for the X bridge that it's being compared against the upper and lower threshold. The lower threshold is 5 volts, the upper threshold is 7. So this signal right here, it's a 0. It's just above the 5 volts, and the 5 to 7 will be right here. So that's the window that we have, and because it's within this window we have cleared the phase loss. If I were to move to 16, it will be a similar signal between 5 and 7 volts, and that signal would tell us again that it's between 5 and 7 volts. It's working, and if we were to have TP15 and 16, we had the 30 degrees phase shift between the two. Now, at this point I'm going to ask Tony to kill the 480 and see what happens to that signal, and compare that. It's no longer within the 5 to 7 volts. 0, 5, 7. So it's below 5. For that reason, now the board is detecting a phase loss. Go ahead and bring it back in again, and there we are. All right. So keep in my test point on test point 2. Now I'm going to move to the output so that I can take a look at TP8 or TP13. So here I have TP13, and this is the signal. These are the two 30-degree long pulse trains divided by 30 degrees, and we obtained this because JU1 and JU2 are installed on the board. If I were to remove JU1 and JU2, then this becomes a single 120 degree pulse, which will be all completely 30, 30, 30, 90, and still have 30 more to make it 120. Again, if I were to open this up, I could see probably there. Let me see if I can find a better trigger. Let me go ahead. We can still see it there, but now let me go ahead. I can now open this signal. I'm probably going to stop it. And here we have this is at 200 milliseconds per division. So we have here a picket fence of about 22 microseconds per division. And again, so I'm going to let it run. There it is. And I'm just closing in on the 2. There they are, those traveling waves. And again, if I were to do that for TP8, I will find the same, and the outputs will be 30 degrees apart from each other. So that's the output. So those are the 6 outputs. Again, we only have outputs on 2 test points. And the last thing that I want to do is I want to show the negated signal of that. So I am on TP13. I'm going to move to TP14, which would be the negated version of that. Alright, so again, if we recall, and now of course this is going all the way up to 30 volts. 0, 5, 10, 20, 30 volts, because it's pull shaping the 30. So let me just close in on that. One channel. If I break this, move this out here, So I have it at 10 volts per division, 10, 20, 30. So these are the times when we are actually chopping and pulse shaping this signal. Thank you, Tony. We're pulsating on this signal every time we have the 30. The very last thing that I'm going to do is I'm going to inhibit the board. I'm going to remove JU1 and JU2. JU1 is out. Okay, do we have a, I got it. JU2 is now also out. And I'm going to go back to test point 8. Because test point 8 is what it shows. And what's it, 13? 13. Either test point 8 or 13 or the output. Go ahead, Tony. Then again, now we no longer see a two pulse trains of 30 degrees. Now we see a single one of 120. So again, if I were to open this up, and I will see there again, and I want to stop this. This is at 100, bring it back to 200. So that I see then again my 22 microseconds per division on my picket pen. So these are typical test points for this board. This is the end of this 32.